All right, now before we really get into lesson 60, using law of sines to find missing angles, we got to go over something real quick here. And if you got a graphing calculator or scientific calculator or your phone, which you could turn sideways and get the sine stuff, I want you to get that out. And I want you to do these first 8. Just type them in your calculator and see what you get. All right, pause the video and do that. Sine of 40 should come out to be 0.6428. Sine of 140 also comes out to be 0.6428. The sine of 50 comes out to be 0.7660. And the sine of 130 also comes out to be 0.7660. The sine of 20 is 0.3420. The sine of 160 is also 0.3420. By the way, you can always get, you can't get, the chart only goes up to 90, but you can do bigger than 90. We have bigger angles than 90. The sine of 110 is 0.1736. And the sine of 170 is 0.1736. Now, notice how these two are the same, right? These two are the same. And then these two. And then these two, right? Now, why does that happen? Now, first of all, you might be thinking, sine is opposite over hypotenuse. How do we even have an angle bigger than 90? We're not really getting into, that's more of like stuff you would do in Algebra 2 as to where that comes from. But it turns out that you can have angles bigger than 90, obviously. In a triangle, you can have an angle bigger than 90, right? You can have a 100-degree angle. It's an obtuse triangle. But you still can do sines for angles bigger than 90. You just don't do it with opposite over hypotenuse. There's another way to do it. And it's kind of has to do with flipping over into a different quadrant. But that's something you'll get into in a future course. What I want you to see here is that when you do the sine of 40 and the sine of 140, you get the exact same answer. Sine of 50, 130. What's similar between 40 and 140? 40 and 140. Or 50 and 130. Or 20 and 160. What's the relationship? See if you can figure out 10 and 170. Why are those pairings giving me the same ratio? Well, if you do 40 and 140, if you add those, you get 180. If you add 50 and 130, it's 180. If you add 20 and 160, it's 180. If you add 10 and 170, it's 180. So when the angles add up to 180, okay, then the ratios are going to be identical. So what do we notice? We notice that ratios, sine ratios are equal when angles are supplementary. All right, so from the above, we can see that the sine of theta is equal to the sine of 180 minus theta. That's something you need to know, that an angle and an angle from 180, they're going to have the same exact sign. Okay, so an angle and an angle subtracted from 180, that angle subtracted from 180 are going to have the same sign. So what this does is it messes up the law of sines a little bit for us. When we go to find angles, we're going to have a little bit uncertainty. There's going to be sometimes two possible answers, because let's say I get the sine of 30, right? The sine of 30 is 0.5, right? We know that. Well, that means the sine of 150 is also 0.5. So if I got 0.5 for a ratio, yes, my trig table is going to tell me 30. Yes, my calculator is going to tell me 30. But we just showed that that's not the only answer there is. There's also an obtuse angle that could have the same sine ratio, and it's whatever the supplement is. Okay, so if you come up with 30, you have to say, okay, 30 or the obtuse angle that pairs with 30, and that's whatever angle adds up to 180. It's like it's linear pair. So let's see how this works. Now, this one says, oh, this is not supposed to say example 1. It's just supposed to be the directions for example 1 and 2. Use the law of sines to find a second angle of the triangle. Use this angle to determine the number of possible triangles that may be formed using the given information. Draw diagrams and find all missing angles and sides. All right, so let's we have triangle ABC here. So I draw one, we'll draw an acute triangle, and then if necessary, we'll draw an obtuse triangle. We don't always have to do that. Angle C is 70. Put that really anywhere you want. We'll just put A here and B here. A is 15 and C is 10. Now, I need C and C with the angle C, see how they're paired up there, to do the law of sines. We know how to use the law of sines. So it's going to be 10 over the sine of 70 equals, and then we could find angle A because we have side A. So it's 15 over the sine of A. So I have 10 sine of A equals 15 sine 70, sine of 70, 15 times the sine of 70, and then divide by 10. Because I'm trying to get the sine A by itself. So it's sine A equals this guy right here. And that, put in your calculator, 15 sine 70 divided by 10 is 1.409. Now, in your calculator, you'll type in second sine, sine inverse, 1.409. And if you do that, you have your calculator, do that now. Tell me what you get. Tell me what you get. No. You should get an error. Okay? You should get an error. It is impossible to have a sine of 1.409. The sine ratio cannot go over 1. So you're going to get an error when the sine is over 1, and therefore there are 0 possible triangles. So that's the answer. Okay, this is not even possible. It can't be this setup. There is no angle that's going to have a 15 opposite with a 10 and a 70 opposite, a different angle and side opposite pair. So this is not possible. Not possible. There are 0 triangles that can be formed. They could ask you that question, is it possible? And if it is, what are the angles? So now number 2 is going to be the other extreme. There's actually going to be 2 possibilities. So I'm going to start off with my acute one. It's so cute. Angle A is 65. Let's put that there. And then this could be BC. A is 22. That's going to be right here. It's opposite of angle A. And then C is 24. That's opposite of angle C. So because they gave me little c, I could find angle C. That's what I'm going to search for. That's going to be my theta. I'm going to find angle C. And then we'll see what happens. All right, so that's going to be, we're going to do 22 over the sine, 22, what am I doing? Yeah, 22 over the sine of 65 equals 24 over the sine of C. So it's 22 sine of C equals 24 sine of 65, and then divide by 22. That's a 22. So the sine of C is 0.9886, and then when I do second sine, 0.9886, that is going to be 81. So now the calculator says 81. So the calculator is telling me that this angle has to be 81. And I'm going to put that here, 81 degrees. Okay. However, it is possible to have a supplementary angle. So if I do the supplement, 180 minus 81, I'm going to get 99. So it's also possible for angle C to be 99, because what's the first thing we did in this lesson? The sine of 20 equals the sine of 160. The sine of 10 equals the sine of 170, right? So the sine of 81 equals the sine of 99. Type it in. Sine of 81 should equal the sine of 99. They're both 0.9886. Okay? So, is this angle 81 or is it 99? We don't know. So we have an acute possible angle or an obtuse angle. There's two different triangles it could be. So I'm going to redraw this guy here with my 65, okay? But I'm going to make a bigger angle. Oh, I'm going to have to tilt it a little bit because I'm going to run out of room. Okay? A 65, and then a bigger angle, a 99-degree angle. See that? So here's my 65, right? And here's my 22, and here's my 24, all right? But what about 99? This could be 99. Okay? So then we got to figure out what this angle would be. Well, we could do that just by subtracting it from 180, right? Okay, so this angle in this case would be 16. So then this would be 16. And then subtract from 180 again, it comes out to be 34. All right, so this is 34. So that's, see the three angles, they got to add up to 180. Just make sure they add up to 180. And then it's just a matter of finding the missing B. All right, so I'm just going to erase this just so I have room on here. I don't want to mess you up. So now that we have these two triangles set up, now I'm finding B. So wait, this was A, this is B, and this is C. All right, so two different possibilities with a 65 there. All right, so now I'm going to do 22 over the sine of 65 equals, now I'm finding x, little b here, b over the sine of 34. All right, so b sine 65 equals 22 sine 34. So this is just like what we did in the last lesson, finding the missing side, just to fill in our table there. So b equals, put this in our calculator, and it comes out to be 13.6, I believe. Yep, 13.6. 13.6. And then the other one, same process. So here's B, and then we're done here. B over, this time it's sine of 16, equals, and we'll just use 22 over sine 65 again. All right, cross multiply. B equals, it's going to be 22 sine 16 over the sine of 65 after you cross multiply and divide it out. And this time B would equal 6.7. All right, this would be 6.7. So two different triangle setups. Two different triangles, an acute triangle and an obtuse triangle. And that's because of the supplements having the same sine ratio. See you in class to practice this uncertainty tomorrow.